Hello students, so today we're going to look at evaluating trigonometric functions of any angle. You're going to want to have your notes, a pen or a pencil, and of course you're going to want a calculator. So what we're going to focus on a lot today is going to be reference triangles and reference angles. So a reference triangle is a triangle created when you draw a line from the terminal side of an angle perpendicular to the x-axis. So what this looks like. So let's say I draw a 45-degree angle right here, okay? Normally you would have said, oh, I'm going to sweep that out, okay? That's kind of what we were doing yesterday. So then you're going to draw, to make a triangle, you're going to take from this angle and drop it down to the x-axis to make a right triangle. Now, please, 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 always make sure it's the x-axis, never the y-axis. You're going to be very tempted at times, but please make sure it's your x-axis. This reference angle, then, is the angle located at the origin in your reference triangle. So what this is this right here. This is my reference angle. And like I said, that was 45 degrees. Sometimes it could be 30, it could be 60, it could be 80. It could be a lot of different numbers. And I'll show you how to find those in the first problem that we do tonight. So, let's sketch the angle, the reference triangle, and then find its reference angle. So I have 210 degrees. Well, I know 210 if I label my sides here. I got 0, 90, 180, 270. I know 210 is closer to 180, so it's about right there, right? I'm going to sweep out that way. To make my reference triangle, you're going to drop a perpendicular all the way down there. Remember, it's the x-axis, not the y. Now, to find my reference angle, notice how from here to here is from origin to my angle. Now, I need to know what is the measure of this angle, just from here to here, okay? That is pretty easy, actually, to find. So I said this was 210, right? Well, 180 to 210. How many degrees is between that? 210 minus 180. I'm going to get 30 degrees. So that is my reference angle, is 30 degrees. It's how many degrees are between one of the 0, 90, 180, or 270 and the angle that you created, okay? So let's try 110. So I have a 0, I have a 90, I have a 180, and I have a 270. 110, that's closer to 90, right? So right here. Now, this is when I'm going to say you're going to be very tempted to make the perpendicular going that way. We want to go to the x-axis. So you need to drop it from there down, okay? So that's my triangle. Here is my angle right here. Now, you can't go 110 to 90 because that's not covering it, right? We're going to 180. So how many degrees are between 110 and 180? We're going to go 180 minus 110. I'm going to get a reference angle of 70 degrees, right? All right. Negative 130 and negative 295. Let's try these. So remember, you're always going to go clockwise when it is a negative value. 100 and negative 130, that's between 90 and 180. Let's just kind of go about right there, alright? Drop my perpendicular down to the x-axis. So now my reference triangle is drawn. My reference angle. How many degrees? So this is 130, right? How many degrees are between 130 and 180? 50, right? So my reference angle would be 50 degrees. Let's try it again. Negative 295. So I got 0, negative 90, negative 180, negative 270. So now, negative 295, that's going to be past 270, so about right here. Drop my perpendicular down. What is my reference angle right here? How many degrees? Oh, I can't ask about 295 to 270, right? That's not what I'm covering. I'm covering 295 to 360. So how many degrees are between 360 and 295? So if I subtract the 2, I get 65 degrees. What if they're radians? This, I think, scares a few people, but don't allow them to scare you. They're actually not too bad. Like I said, you can't really think in radians. I know I have a hard time, so let's convert this to our degrees. So I'm going to have x over 360 equals 5 pi over 3 divided by 2 pi. The pi's are going to cancel off, so I can go 5/3 times 360. So 5 divided by 3 times 360, I get 600. So I'm going to get 2x equals 600 by cross multiplying. Divide by 2, x equals 300. That's my degrees. So now I can label my sides here. 300 is pretty close to 270. Drop my perpendicular down. Okay, what would be my reference angle right here? How many degrees between 300 and 360? 60 degrees, right? So that would be my reference angle of 60 degrees. Finding that reference angle is very important coming up. So please be able to find that reference angle. Let's convert this guy. So I'm going to have x over 360 equals negative 7 pi over 9 divided by 2 pi. Pi's cancel off, so I can go negative 7/9 times 360. I'm going to get a negative 280 divided by 2, negative 140, right? So I gotta label mine in counterclockwise position this time. Negative 140 is really close to 180. Drop my perpendicular. So this is 140, right? How many degrees between 140 and 180? Well, that's just 40 degrees. So my reference angle would be 40 degrees. Now, what is this going to do? By understanding the reference angle and reference triangle, we can now evaluate these 6 trig functions for the triangle that we create. So here I have this angle that's been swept out right here. Theta degrees. They created a reference triangle. Dropped it down perpendicular to the x-axis. Notice, don't forget that. And now I have this xy point right here, right? Well, what's really kind of cool about this is that x and y relate to the sides of this triangle. So let's take a look at actually how this looks. So I'm going to evaluate the 6 trig functions of theta given negative 4/3 as a point on the terminal side. So let's actually figure out what that looks like on a coordinate plane, right? Negative 4/3. I'm going to go over 4 and up 3. Right there. That's my point. Now, if I connect from here, the origin, to there, and drop down a perpendicular, it's not very good perpendicular, but nevertheless, I get a triangle like that. Now, how big is this? Well, it's negative 4, right? That was the side that we made. That's how far we went out. And we went up 3. So my sides of my triangle are negative 4 and 3. So let's kind of draw this off to the side so it's easier for us to see. I need to find this other side. What in our toolbox allows us to find something the other side of a right triangle? Pythagorean theorem. So I can go 9 plus negative 4 squared is a positive 16. I'll get 25. I'm going to square root that. So we're going to have 5 right there, right? Now, putting my theta, I'm going to put my theta right here. You're always going to put it in the corner that's relating to the origin, where the origin started. So you're never going to put it up in this corner. You're going to put it in the corner over here. So here's my theta. Now, hard part's over. We just need to evaluate some trig. So sine, remember, that's opposite over hypotenuse. So my opposite is 3. Hypotenuse, and then there's my adjacent. So opposite over hypotenuse is 3 over 5. Cosine would be negative 4 over 5. Tangent, opposite over adjacent. 3 over negative 4. Now I can make that negative 3 over 4. Doesn't matter. Cosecant is the opposite of sine. Remember, it's sine flipped. So 5 over 3. Secant would be 5 over negative 4 because it's cosine flipped. I'm just going to rewrite that with the negative on the top. And cotangent will be negative 4 over 3. Not too bad, right? Once you draw the triangle, it's actually not too hard. Let's try this again. So I have 3, negative 3 on the terminal side. I'm going to evaluate this. So graph that point. 3, negative 3. Right there. Connect from origin to dot, dot to x-axis. Please always make sure it's the x-axis. So my sides are 3 and negative 3, right? And then what would be my hypotenuse? So let's figure that out. So I'm going to go 9 plus 9. I get the 18. So I'm going to get the square root of 18, right? Using Pythagorean theorem. I don't like the square root of 18. I think there's a perfect square in that. So let's break it down. I think a 9 can come out and a 2. So I'll get 3 root 2. That way it's a lot easier when I can simplify. I'm not going to have to break it down every single time. So if I draw this off to the side here, just so I can kind of see my triangle, I'm going to have a 3 root 2 over here, a 3, and a negative 3. Here is my theta. So I have the hypotenuse here, the opposite here, and the adjacent there. So sine, opposite over hypotenuse, 3 over 3 root 2. Notice my 3's cancel. I'm going to be left with negative 1 over square root 2, which is negative square root of 2 over 2. Cosine. Cosine, I'm going to get adjacent over hypotenuse, so 3 over 3 root 2. 3's cancel, left with 1 over square root of 2. Rationalize that denominator, so you're going to multiply by the square root of 2 on the top and bottom. So you can get square root of 2 over 2. Tangent of theta, that's opposite over adjacent, so negative 3 over 3. That's just negative 1. No problems there. Cosecant is sine flipped, so that's negative square root of 2. Remember, whenever you're doing cosecant, always start with the non-ones. If there's a radical on the bottom, just start there. Don't use the one where you've rationalized the denominator. Otherwise, you're going to have to flip it again, and it's going to be a lot more math. Work smarter, not harder. Secant is going to be the square root of 2, because that's this flipped, right? Cotangent is 3 over negative 3, aka negative 1 yet. And that's the end of this video. See you later, Sabers.